Right, so we have 4 quizzes today. Okay, 2 of them is something about memory and retrieval stuff, and 2 of them is talking about the problem solving aspects. So our first question is about this one, and the first question is about the increase in reaction time related to an increase in the number of facts associated with the concept is called what? So you know, in the long-term memory, okay, if you have more knowledge in here, it takes more time to get out. What is called that? Fan effect, or interference factor, or Ingram coefficient, or chunking dilemma. Okay? Right, very good. So, as the first quiz after term break, so 70% is quite good. So we can use to do it for second question. Okay, second question is that, can you read it? So the fact that individuals are more likely to remember stimuli presented to them previously if the contextual cue are the same at encoding and decoding is referred to as what? So the question is, okay, very simple. So if you remember some of the word in dry environment, make it simple, okay? So we've been to the workshop, right? If you have to remember some fact of myself, the Hokyung, because when we get used to, it's a drinking time, right? So if you want to remember about me, you have to get it again, the same context, the drinking time. So when you remember some of the word in drinking, you have to go into the same context to remember that word. Very unusual circumstance, but that experiment done by the Alan Baddeley explained, context can give us some clue for encoding and decoding. So what is this for? The first one, external facilitation effect. And second one is peripheral cue phenomena. Or this is Tolbing effect. This encoding specificity principle. Some of the word I have changed it, okay? But you have to keep in mind what is the keyword in this question. So I will give a 2 minute, 1 minute, 30 seconds? 10 minutes. 10 minutes? Okay, so I will give 2 minutes and take time. Why you believe that is the encoding specificity principle is that one. So if you can, in multimedia environment, you can put the multimedia information in 2 different ways. One is visual information, the other one is spatial information. Okay? So that is encoding specificity principle. Okay, some of the knowledge go into the spatial working memory. Some of them go to the phonological loop, right? Visual spatial sketchpad. So that's why we can do multitasking that is kind of encoding specificity principle. But this one is context issue. So if you can give us some context to you, you can have cued recall. Okay, context is a cue. Get it? So like what is audition English? Okay, in the week 9, the last week, I mentioned about some of the example of the English learning application. But that is give us some context, because context give us some kind of clue to remember some of the English sentence for that context, that situation. That's why context-based learning is beneficial than non-context or non-independent learning module. That's the thing of the why the cue is important. So that is called peripheral cue phenomena. Answer is B. Right. Go to the third one. Right. Third one is about problem solving. Okay. I mentioned last Thursday, I explained about the human problem solving approach. But of course, this was a question about Sultan, the chimpanzees, right? But why? I mean, which of the following is not the essential feature of problem solving? Goal directedness. Human is very similar with the Sultan. Only difference is some minor stuff. Or feedback, operator selection, and solve-goal decomposition. I used the blackboard on Friday to explain people do something, but I mentioned one missing part of Alan Newell and Herbert Simon. Do you remember that? Alan Newell and Herbert Simon didn't include something. The same with this one. Goal directedness or feedback or operator selection or sub-goal decomposition. Okay. 1 minute is enough?
No.
Who said no? Yang Hwan. You did it? Okay, 2 minutes. Same eyes. The answer is what?
B.
Yeah, it is B. Ooh, 95%. Very good. Okay, so when I use the blackboard, I use the goal, sub-goal decomposition, and operator selection. That is basic principle of Herbert Simon and Alan Newell's GOMS, goal, operator, method, selection rule. Okay, very good. Right, you remember some part of it. Okay. Unfortunately, last question might be a little bit harder. A little bit harder. That is last question of us of today, and that is very important. Why the GOMS or GPS? That is first artificial intelligence application. The GPS, not global positioning system. GPS is general problem solver. Okay, not global positioning system. Okay, the GPS, Alan Newell and Simon, is computer simulation AI, first AI program using artificial intelligence solve the Tower of Hanoi. Tower of Hanoi. Right. So what this GPS used? There are three approaches in human reasoning process. One is backup avoidance. And something about goal, we're just looking for the suboptimal, isn't it? Okay, when I use some branch, like this one, don't you remember? So human information search has a limitation, likewise, okay? To find the solution, we never go in this way, because that is -10. That is human. So we are not doing forward reasoning much. We're just doing the backward reasoning to avoid the backup. But only one technique being used by the GPS can do this all search. Okay, so might be this one is 1000. That's why this one might be optimal solution. Right? That is one approach used by GPS. Ready? That is too easy, isn't it? Because you read the textbook. Okay? So I can give you 1 minute. Oh! Ooh. Ooh, you're very good. Okay? The means engine analysis can do the global search to find the answer, right? So that's what GPS is tricky. I mean, it's not tricky. It's GPS has some advantage other than other applications. So, very good. Okay, so we go for the lecture then. Right, well, today's lecture is about the last part of problem solving, and this problem solving issue is linked to the decision making next week. Of course, next week, before taking the decision making, how people do the decision making, we have to know some expertise, how we build up expertise. But today's, well, I'm focused on creative. Why people cannot find unusual answer. Why people? I mean, you know the many people, Einstein, Albert Einstein, Isaac Newton, they call the genius using creative thought. Why people cannot find such a nice answer or solutions. So that is linked with the problem solving. Why we cannot do some problem solving very effective ways. One of the reason is called this one. It's Myers 1931's experiment. So what does it look like? Stretching? Okay? They have to, I mean, the main job in this room is they have to hold the 2 strings. But that is wide enough, so people cannot reach 2 strings at a time. There are a couple of items in here. The pliers, tack or nail, chairs, some of the jar, paper. There are heaps of things. If you are in here, how can you reach the other string?
Pick the other one first.
You swing it. You swing the string and then find the best time to hold up to a string. Wow, it's clever. You're creative, right? Very creative. But we have to use some of the thing. I mean, that is one of the options, but at that experiment, they didn't do that. But Myers experiment, I mean, of course in this here, the idea about this, what? Using what? Using food. You chimpanzees, you can use your toes to pick up the string. Only two toes. Okay, whatever. Okay, good. Oh, that is not creative. That is kind of crazy. Okay, isn't it? But anyway, okay. The idea about this Myers experiment is this one: why people cannot use the plier in here, or chair, or the jar. The best solution is they have to use the plier, put in the string, and then using like a pendulum, like a chew, like that. So like similar with your idea, but you never used any items. But this experiment is using some of the plier item to like pendulum, and then catch it, right? So it is called functional fixedness. Okay, the idea is this one: people has a functional fixedness. For example, if we look at this chair, we know what to do, right? We never throw these chairs because that is their function, sitting on, right? Okay, you get it? So if you look at the plier on the floor in the previous picture, you believe that the plier is only pull out the nails or something else. It's not for pendulum, isn't it? So that we people, when you have an answer or when you have a solution, so we keep using the same solution and we're using this one forever in the same ways. Pencil, always write down, isn't it? Cup, is hold the water. Okay, functional fixedness is like this one. Sometimes solution to problems depends on solver's ability to represent the object in novel ways. So 2-string problem. We are fixed it, one function of the object. So that's why we can find it. Same experiment is done, Dunkers in 1945 in the candle problem. The task they have to complete is this one. They have to put the candles on the door. Is there any door? I mean, it's not door in here. But only they have with this one. Tack, right? And some of the box of tacks, candle, and match. The task is they have to put the candle on the door. Likewise this way. In here. The same experiment with the Myers experiment. How can you do that?
Light up the candle when in the top, put some candle on the wall.
You're just melting some part of the candles and then put it in here like that. Oh, that is idea. That is idea. But it's not lasting long, isn't it? Because of the gravitation. But it works. Put the text. You say that is candle. Okay, if that is the candle, and then using tag in here. Yeah, that is functional fixedness. Just he trying to use the tag, always same for some pinching down and pushing down, right? Isn't it? Use a box. You can use the box in here, right? Put the box, if that is a box, do you have any box? If that is a box, okay, using a tag to put the box in here, and then there is some kind of width, isn't it? Length. So you can put in here like that. The reason why, the interesting part of this experiment is, that is functional fixedness plus the second one is more good implication. The second experiment is done. One is with the heaps of tags, 앞정, tags. Okay, tag means 앞정. Okay, and the other one is without tags. The couple of tags on the floor. Two difference, get it? One is heaps of tag in the box, and the other one is tag is on the surface of the chair, the desk. Get it? So what do you think? Which one can be more close to the right answer to use the box? Empty box, right? Because when you see the empty box, now we have some kind of idea, oh, we can use the box. Right? But if the tag is within the box, heaps, so we are not thinking much about to use the box because they believe the container of the text. So we are not using this box for some other purpose. So that means why people cannot solve the problem creatively, because we have some kind of fixedness to the answer already known. Okay? So that's why 2 by 2 is 4 always. 2 by 2 cannot be 5. Okay? Sometimes 2 by 2 can be 5. Okay, that is summarize of functional fixedness, the tendency to represent object as serving conventional problem-solving functions and thus failing to see that they can solve novel functions. Same, we have the, because, okay, this one. The second one is really interesting experiment. It's done by, I forget, who's that? Right, idea is this one. Second, okay, functional fixedness is one thing why we cannot find the creative answer. Second issue is the set effect. Okay, I can explain what is set effect. Okay, so we have 3 jugs. Well, 3 jugs. The jar, okay, that can hold 5 liters, that can hold 40 liters, that can have 9 liters. So we have to make 19 liters. Okay. Just assume that you are in the sink, so in the jar, okay? You put every water, there's a taps as well, so you can do anything you want, okay? So that to make desired liters, the water level. How can you do that? Such as, we can use the 2 times jug A plus 1 jug C, make 19 liters. Second, how to make a 58? Okay, we can use the 2 jugs, okay, 2 jug A and 1 jug C. 15. Second, third, sorry. 1 and twice, isn't it? 1 jug A and twice jug C. Okay, okay. So you learn it? I get it? Do you understand it? Huh? Right. What is this one? How can you make it? Two jug A, 1 jug C. Right? Make a 33. Okay, next one. Okay. See? Can you see the difference? You cannot make this one. Can you? Huh? Oh, anyone knows it? Oh, simple arithmetic. 2B? 2B plus 2C. Oh, 2B plus 2C. Okay. Okay, 2B plus 2C. Okay, so another one. Oh, 2A minus B. Okay, so you find the correct answer, but what this experiment for is very interesting. Okay, while you're doing this exercise with me, you keep adding it. 2A plus 1 equals 19. 2A plus, so that is called addition set. Plus set. right? Because you exercise with the plus, and then I give a same exercise, the plus exercise, but last one is minus exercise. So you find this one first, then this one. This one take time to find it because you practice all the plus stuff for last 4 exercise, but suddenly when I give a minus exercise, you keep trying to think that is the plus exercise, right? So that is set effect. Set effect means the problem solving strategy is primed by your previous experience. That's why that is a much faster answer. Of course, 2b plus 2c is slower than this one because 2a minus b is much faster. But this one is take time to get it out for your problem solving answer. Get it? Okay? Set effect means this one. Yeah? People can become biased to the prefer certain operators when solving a problem by their experience. Okay, so we are biased to a solution with the previous exercise. We have heaps of set effect. That's why we cannot find the right answer in some times. Okay. Yeah. Result when the knowledge relevant to a particular type of problem solution is strengthened. Likewise, this one. Okay. Okay, number 1 to number 8 and number 1 to number 10, problem number 1 to number 10, except number 8, you can find one solution. What is it? B minus A minus 2C. Okay. B minus B minus 9C? Is it working? Is it? B minus 9C? I say from number 1 to number 10, except number 8. That applies everything. Is it right? B minus A minus 2C? Okay. You have to find one rule to cover 1, 2, 3, 4, 5, 6, 7, 9, 10. It's wrong, isn't it? All of them wrong. A simple arithmetic.
B minus A minus is
It's right. B minus.
A minus 2C.
B minus A minus 2C is right? Okay. B minus A minus 2C is right? Okay. That's fine. Right. There are 2 experiments in here. Okay, there are 2 experiments. I'm not playing with you guys, but I'm just explaining the experiment done by this Luchin's experiment about set effect. There are 2 different experimental conditions. Okay? Right, I will explain it. Okay, look at that. So one group A, the participant group A, and group B. 2 different user groups, like one you did in the experiment with me in a long time, last week. Right, group A solved the problem 1 to 5s. Okay, group B, they never solved the problem 1 to 5. Okay? They exercise 1 to 5. They never exercise 1 to 5. Okay. Now, main experimental condition is done. Given problem 6. So what do you think? So look at only number 6, this one. Group A, of course, if you believe the set effect is working, they will use the same B minus A minus 2C, isn't it? Is that the simple solution for problem 6? What is simple solution for problem 6? Yep, A minus C, right? So they simply count how many people use this one. Okay, same thing. So which one is, so group A, most of the people use this one. Group B is use this one. Of course, group B doesn't have any set effect, isn't it? But they didn't do any exercise from 1 to 5. That is how the set effect is proved our problem solving. So I summarize it. Number 7 and 9. Same experiment. What is a simple rule? Yeah, A plus C. So that is addition set. Okay. But many people, when they have a subtraction set, they couldn't find the plus set. I mean the addition set easily. That's how the Luchin's trying to explain it. Okay, that's the thing. There's water jug. Problem is induced mental set in their research participant. So Einstein effect is we are trying to mechanize, pretty much automatic, mechanize of our thought. So the report to the set effect. Okay, that is what. Okay, that's the thing all about set effect. Another experiment with you guys. Okay, this one, another set effect. So this one is only applied for the mathematics, isn't it? So number, arithmetic. So whether set effect can also applied in our normal life, such as word or picture. That's why we sometimes very difficult to find anagrams. Anagrams, likewise this one. Safran's 1962. They made a very, so I will show you the 5 words. So tell me what it is. All of them is same. It's something for the one purpose. All about what? Drinking coffee. But when I give you, before I show you these 5 words, when I give you say, okay, these all 5 words is about drinking, you can easily find this one is milk, sugar, sweet, cream, coffee, drink, right? But if you are never given about this kind of cue, so it is very difficult to find it. So set effect like happens in normal life. When you set yourself in a certain environment, you can't see the different solution. I mean, it's difficult. To avoid this one is you have to give us some kind of instruction like drinking coffee, and then you can easily find it. That's why when you make some application or information design, if that information is really hard, you have to give help. Help means instruction. Every application has help. Right? That's the basic principle behind from this experiment. Right. So that is really debatable experiment, but many people believe that. So if we cannot find a creative solution, what could be the best way to find a creative solution? So that is one of the effects called incubation effect. What is incubation effect, you guys? Seungmin? Just don't read out. What is it? Incubation. Incubation means incubator. You know the incubator? So, kind of idea. So if you cannot find the answer of the particular problem solution, the solution of the particular problem, you have to leave it down. And sometime later, coming back. Don't try to solve right now. It takes time to solve the problem. So which means it's set effect. Basic idea about incubation effect means, okay, if you cannot find the answer of a particular problem, you keep setting yourself to find the solution of this problem, right? Forever, 2 hours, 3 hours, 5 hours, you keep focused on it. So, and then you send yourself in here. To avoid the set effect, you have to leave it behind, okay? Leave it. And then play outside, meet your boyfriend or girlfriend, drinking, right? And then coming back, right? It can help. I do the same thing when can't I find some of the solution for my experiment or idea to process my article. I normally get to some sleep, the napping. or drinking, or play with someone else, one of you guys, okay? Okay, like you have the time off. So that is the incubation effect. It is proved by the experiment. So likewise this one. Idea is this one. Very simple. Very simple. Okay, so this experiment is done this way. When you look at one of the pictures is given to you, you have to let me know of best praise similar with this one. So for example, this picture when you see it, reading between the lines, such as, and this one is, what is it? This one is such high and low. Of course, this one is the English experiment, so that this one is not the frequent praise in Korean, but that is kind of experiment idea. The only different condition is this one. The relevant praise about this picture 3 is, what is it? A hole-in-one. The goal, the hole-in-one, right? But point is this one. I just give an instruction. This one is chemical code. The experimenter said, okay, this one is chemical code. Okay, 2 different groups. For the picture 3, so what is it? Sungmi, what is it? I can't see it on the back. OH, OL, okay, something like that. So when this one is given to the participant, right? So one group A, okay, group B, okay. So they believe this one is chemical code, right? Right, group A is being asked to find the answer of this one for 2 hours. Keep thinking. Okay, 2 hours, within the 2 hours, they have to find what is that means. Okay? And this group, same 2 hours, but 1 hour walking, and then 30-minute tea break, coffee. Okay? And the other 1 hour. Which one could find the answer more? In terms of incubation effect, so B is better. But one of the debatable issues is, within this tea breaking time, whether people actually think about the question or not. Oh, that is a major limitation of this experiment, because some people have, this group A only solving the problem in 2 hours, this one 2.5 hours, and basically. If they are thinking the same question about this one in a tea breaking time, but they give, the experimenter, give something unusual task within these 30 minutes, so they couldn't do any thinking about this question. So that to avoid these kinds of issue in experiment, they made balance situation group A and group B, and find that incubation effect could be useful to find the solution. Okay? So if you have any difficulties, okay, to find the solution, take time off. Okay, meet the friends, can drink. There's beauty of we did, right? Last week. So last answer, this textbook doesn't cover the creativity, but I summarize some of the creative issue in 4 ways. Some people say creativity is depending on how many you know. So depending on your knowledge level, you can make better solutions. That is what the Torrance test of the creative thinking. You can do this test on the online. So using heaps of different objects is given to you, and then you have to find how many different answers you can find. So using this number of items you make, so you can see how much you are creative or not. And the second one is one you know. Depending on what you know, so you can find quite unusual answer, diverging from the old thought, such as Isaac Newton, Charles Darwin. Okay, they are creative because they already know many of the knowledge about something, so that they want to make that that doesn't make any sense, so they're trying to make a new one. Okay, so that's the why when you know to divert from based on, and some people believe that that is personality. Some people has a creative idea rather than the other people. In particular, Csikszentmihalyi, the motivation is very important issue, who you are. So we will discuss this one in week 13 and 14 when you do the organizational psychology. The main theory is a self-determination theory to say why motivation can improve your creative thought. I'm improving you, I'm just encouraging you to have likewise the motivation. Last one is Csikszentmihalyi is one of the important psychologists and positive psychologists, not that research domain is positive psychology, it's not cognitive psychology. The Csikszentmihalyi say, very important issue, say the creativeness comes from the society, such as Isaac Newton. At the time, many people in Europe doesn't want to believe the God is the center. Earth is not the center. So that's why the society give us some kind of hint to Isaac Newton to make that kinds of the law of inverse. 만유인력의 법칙, the law of inverse, isn't it? Inverse distance, the law of inverse. Yeah. Charles Darwin at the same time. So people doesn't believe the God is existing to make us. It's not creation. So they want to make the totally new one. So that's why evolution theories comes from the society. That's why the Csikszentmihalyi say that is creativity. I don't know which one is right, but four of them is major discipline to understand the creativity. That is chapter 8. Now go to chapter 9. Expertise. Okay, so to do problem solving, you need some expertise, experience. We need the expert. Because you have expertise about industrial engineering, and I have some expertise on cognitive psychology. Some people has expertise on chess, game, right? Playing something, soccer. Whether this expertise is inborn or innate or obtained, that is a major issue in cognitive psychology. Expertise can be improved by practice or not. I mentioned in a long time ago, such as architect. Whether architect has a high spatial working memory, or those who have a high spatial working memory can become an architect. Chicken or egg, nature or nurture. That is the issue. Cognitive psychologist is interesting how we can develop the expertise. Okay, and then if expertise can be obtained by the practice, we can make what? Nice education system. So cognitive psychologist from that point on goes into the educational discipline. So we have to define our knowledge level. And then when you understand how we can build up our expertise, we can make very nice tutoring system, very nice e-learning system, very nice e-book, game, serious games, that sort of thing. That's why I'm doing the serious game for my research. So one of the things, brain changes with skill acquisition. Okay, as people become more proficient at a task, they seem to use less of their brain to perform the task, which means we are economical, very economical brain activities. When you learn something very unusual stuff, it occupies many of our brain area, likewise. But when you get used to do it, so we can use a very small part of our brain. Is it? That means we are obtaining some of the skill with a very less working load. But the extent practice is important. So when you do some practice, we can have expertise. That's what we're trying to say in here. Right. 3 stages is the major part. So all the psychologists identified these 3 stages is important. Rasmussen in week 5, I mentioned the Rasmussen's SRK framework. SRK? Rasmussen. Skill, rule, knowledge. This one, the Fischer and Posner, they mention very similar things like cognitive stage, associative stage, and that is automatic stage. So we can just mapping that is automatic, associative, that is cognitive. So all these two is talking about human knowledge expertise, human expertise starting from very thoughtful process, and then when you have some practice or exercise, you can have very automatic learning, right? Very automatic. The skill means this one, automatic. Like you're driving. For your beginner driver, the novice driver, you should be very attentive, and then you have to change the missions, and you have to read the traffic sign, everything. You need to be very careful, right? You need to be. And then probably you can tell me, if you're a novice driver, you can tell me how you get to school from your home. If you're a novice user, you can tell everything, every detail. So for example, in Seongsu Sagori, so you meet the big car of the truck, dump truck, so something. You can explain to everything if you're a novice user, but if you're really experienced user, you never know how to get to school from your home. You're just driving it. You can't tell much thing, isn't it? Because you already know that is skill. So that your body, your hand already know how to drive it. So you don't need to pay any attention too much, right? That is level of skill, right? A knowledge level is beginner. That is expert. Point is, in this chapter, the point is how we can describe expert knowledge. So that is a major issue in cognitive psychology aspect. So how we can define the expert knowledge? If we can pick up the expert knowledge, we can make expert system, isn't it? The computer scientist can use this knowledge representation, if that is that. So we can use this one, the computer scientist can make it expert system. So industrial engineering, for example, like Professor Lee, Dong-Ho Lee, so he's expert in production system, right? If I want to make a production system, the expert, so I can just use his knowledge, right? Put in here. But that is problem. How? We don't know yet. Very difficult to define it. That's why the ACTL is using some of the networks, semantic networks, some of them use the production system, some of them is interview them to find what is the main knowledge of the expert. But ideally, so if we can describe the expert knowledge, we can make an expert system. That is dream of education practitioner. So I'm teacher, for example, the physics teacher or chemical teacher, chemistry teacher. If I can describe my knowledge in an effective way in a computer system, student always can access to this expert system to learn chemistry, physics, mathematics. But that is difficult. That's why we make very different types of education system. Sometimes we try to the game, using the game, sometimes using the interactive version, right, to teach the children or students. Sometimes we're using the very textual information, multimedia. We try everything, but we don't know exactly what is the best one. So that's the main issue of chapter 9. How we can define expert knowledge. So, to understand that, the first stage of the human expert is starting with cognitive stage. Okay, so cognitive stage is about declarative knowledge. We create declarative knowledge is implicit memory or explicit memory. We have 50-50 by chance. Explicit knowledge. Okay, declarative knowledge is something about that. Yongjun is stupid. That is declarative knowledge, right? But procedural knowledge is implicit. Procedural knowledge is implicit. Such as, how can you say how you can tie the shoelace? Very implicit, because there are many different ways. But Ho-kyung is the professor in industrial engineering. That is fact. The declarative knowledge is explicit knowledge. Okay, what the Fisher and Post in 1967, they found that the first stage, if you want to get some expertise, you need the declarative knowledge of a fact. Like driving, for example. So, how you can change the transmission from drive to parking. The wheel movement, foot brake. You have to remember everything about this fact. Otherwise, you cannot build up next level of expertise. What is next level? Associative stage. Okay? So from in here, so beginners will make heaps of errors, isn't it? They will do. They may have bumped into the other cars. They may, have a big accident. While doing, they have many of errors and many of practices. They can go into the associate level, such as rule. Okay, they can develop their own rules, such as if car in front of me is a Lexus or Mercedes-Benz or BMW, I have to have more distance. Such as, that is a rule. Okay? You know what I'm saying? That is a rule. If you have the expensive car in front of me, you have to away or run away. Otherwise, you might be in trouble. That kind of rule can be developed by these beginners when they have some kind of experience. The first one, errors in the initial understanding are gradually detected and eliminated. So connections among various elements required for successful performance are strengthened. So it's kind of practice. Okay? So the thing about the last stage is, okay, for example, make a simple the picture. Say if the knowledge the beginner have to remember is 1, 2, 3, 4, 5, 6, 7. The middle layer people, the intermediate people can remember only 3 rules. This one may be 0 or 1 rule. Because they don't need to remember the rules because all their body already know how to respond. Okay? So that is a picture, but in here, connection among the various elements required for successful performance and declarative representation of skill is converted into the implicit memory. So this one is declarative knowledge. Okay, fact about everything. Okay, this one must go into in here. Likewise, it's not declarative anymore. It's kind of procedure. Implicit. You can't explain it, but you know how to do it. That's why the expert knows how to do it, but they can't explain it. Most of the experts, it's very difficult to explain how they solve this problem. Like a chess player. The king of chess, chess master. So they can explain, what is the Go master? Isedol? Isedol. The Go master in Korea. So he can't explain how to move the next one. But I mean, he can't explain because he wanted, that is that. Okay? So that's why the expert knowledge is very difficult to retrieve it. All their knowledge is procedural, sometimes a pattern. So we can cover it, why the pattern is important for the chess player. Okay, they remember the patterns of all the information. So some chess master remember 50,000 different picture of the movement. 50,000. So that's why when they see all the framework of the chess, they know how to do it for the next move. Right? So that is kind of thing. So second stage, okay, declare knowledge is now start to declare knowledge into procedural knowledge. Last one is, that is automated, like skill. So no rules, sometimes, just done it, okay? So this second stage is same with our SRA framework, SRK framework by Rasmussen, right? Learning curve. Just kind of this one, simple, the learning curve, like this one, okay? Sometime later, it's pretty much saturated by learning curve. It's not important much. Okay, the important things which we'll cover by next week, but I'm just skim read it, couple of factors, like how we can develop our expertise. First one is, as we just said, factual information, the declarative knowledge must be converted into procedural knowledge. Okay? So that's why if you want to make education program, you have to think about declarative knowledge, such as 2 + 2 = 4. Okay, that is factual knowledge. Okay, how this declarative knowledge can be converted into procedural knowledge, such as how to teach add, how to teach subtraction, how to teach timetable. Okay, that is the things. And tactical learning is practice. But what kinds of practice? That is linked with this one, or this one. Deliberate practice, the last one. Okay? Deliberate practice. Practice itself doesn't improve your expertise. Do you know what I'm saying? Practice doesn't improve your, for example, I play every day 10 minutes pianos. That is not true, but I mean, I never played it. I have no time to sleep even. So, okay, if you play 10 minutes without any intention, it doesn't make you a pianist. You have to rehearse by your mind, and that is called the deliberate practice. Only deliberate practice make you have expertise. That's why I have an expertise on cognitive psychology, human-computer interaction, and serious game. I don't have any expertise on LP, algorithm, something. All of them is I don't never know. Okay, so production system. Okay, or in the mornings I met Professor Kim. 6:30 in the morning. But he explained some of the algorithm to me, but I never know anything. So the Voronoi is something. 6:30. It's killing me. Okay. So the last one is pattern learning. The Voronoi, very important thing. Pattern learning. Pattern learning is, which I said, what is it? The chess player and Go player, they can't remember all the procedure of the movement, right? But they can remember the patterns, right? That's the whole things I can discover next week. Okay, that's it. So we can just stop right now, and then we can come back tomorrow morning then. Okay.